Okay, so good afternoon everyone. It's 1:30. Welcome everyone to Com 2160 again. So how you guys are doing? If anyone can just chat or just speak like is the sound is clear and you can see the slide, that will be better for me. Good. Okay, yeah. So we can start. So it's very tough situation all over the world, right? So in Winnipeg, so far 17 cases, and in Canada, so far I think 750-ish. So in British Columbia, in Ontario, it's really, it's very bad situation, I should say. So we have to be very careful. No party, no social gathering, like until the situation get better, right? So you have to be very careful, isolate yourself, no gathering. So we should start. We are kind of lagging behind. So this is kind of the very first lecture of this week. So I will try to maybe just record the topics and just upload the video if I can, or if I can manage the time, or so for from now, like, we can continue our regular classes. It's though online though. So whoever is not joining, I will just upload it to the Learn, the video we are recording here, so we will be good. So whoever cannot join, they can also see the video later. So the assignment 3 is already uploaded. I think you are working, guys. So I am really appreciating who are like post some question in the discussion forum. So for the first time, I think I saw some questions regarding the assignment in the forum. So I'm kind of answering those also. So far, like, it's updated, no more questions so far. So I will encourage you to post in the discussion forum rather than emailing me. So if you email me, it's just between you and me, but if you post it in the forum, you will know that so all of your friend can see it. So if someone has the same problem, he or she can get the idea. That's the the main benefit of posting anything to the forum. So I will encourage you to do that. And what left? So we have lab 6 coming on, the very last lab next week. So there is no in-person lab. So I will post the lab 6 very soon, and you need to upload your solution, okay, in Learn, and the TA will check that. And also in your scheduled lab time, the TA will be available, maybe by the Cisco WebEx things. I will request him to be available so that you can ask any question or email during that lab time if you have, for sure. I think we should start now. So today's topic actually optimization. So if you can remember the last class before this COVID-19, we were in like kind of the maybe I can go to the next slide. So last class we talked about, like, suppose you have a program and it's kind of getting slow, then what are the things you can look at? Maybe you can go for printf, but it's not a good idea. And then we talked about the profiler things, right? So whenever we use this profiler, you have to remember some kind of command, or like some kind of keyword, right? So just to recap, whenever you use profiler, whenever you are using the command clang -wal, then the program name, you have to mention -pg, right? That's your profiler. And then you just need to run that program. And then whenever you run, there will be an extra file created in the same directory. It's called gmon.out. And then our command is gprof, and then the name of your file or the executable file. So that's how it will show that which process takes how many like call, and like which process takes how much time to run, so you can have the idea, right? And then we went for the space optimization thing, like what kind of things related to space optimization, or what we can do, what kind of idea like choosing a better data structure will be better solution, something like that, right? So we'll continue with that optimization things today. Like it's basically we will go for the bit manipulation. Like previously, like whatever we have learned, we just assume that whenever we use char, it will take 1 byte, depending upon the machine. But what about like if we go for the bit manipulation rather than the byte things, okay? Then how we can use these bit fields and see. And then the very last topic will be the void pointer. Like whenever we create a pointer, we mention that what kind of pointer is that. But rather than that, can we just use a void pointer in C? Okay. So let's start. So at first, how we can manipulating bits. So you know that all the values in memory actually represented as bits. So inside the memory, whatever program you are writing or whatever code you are doing, it's actually zeros and ones in the memory, nothing else. Okay. So whenever we want to do the bit manipulation, rather than the signed things, we'll go for the unsigned. And how we can declare a variable with the unsigned is just like whatever the data type you have, you will just put unsigned before that. So suppose if we are declaring integer for unsigned, it will be just unsigned integer, unsigned short, unsigned long, then unsigned character, just like that. Okay. So what's the benefit of this? Actually, you are getting bigger number, right? So whenever you suppose it's a 32-bit machine, and then you know that if it is signed, then the very first bit gives for the signed purpose, right? So then your space is between -2 to the power 31, because 1 bit for it's 32-bit, but 1 bit for the sign things. So -2 to the power 31 up to 2 to the power 31 minus 1, including 0, right? But if you have this unsigned, actually we have from 0 up to 2 to the power 32. So it's bigger than the signed things, right? So then the next point, actually, if you got overflow, like if it is just maybe you are having this up to 2 to the power 32, but what if like if you just add one more, it will just make 0. Okay, so this like the pointer, this is the one, so this is actually a dash or hyphen, it's a bullet point. So it's not -2 to the power 32 plus 1, it's basically 2 to the power 32 plus 1, it will give you 0. So whenever we have overflow, it's going to 0. And we have like reliable bit manipulation with this unsigned things. Okay, so you will learn lots of these things in COM2280 also. Okay, so far if you have any question, you can just turn on your microphone and then ask me, or you can have like in the chat you can ask me any question if you have. Okay, so if you have any question, you can ask me. What is that question for? I don't know. Anyway, so or you can chat. Okay, so okay, so I can see like when we get midterm mark back. So actually, so you have to you know that in learn. So all the time you get some notification, right? So if you go to the course home, there are some news, updated news, right? So you have to follow those, right? So if you go those updates on news, like I think like 3 times I said that Tuesday morning the marks will be uploaded. So on Tuesday morning the marks were uploaded actually. So you can just go to your grades. You will see your mark if you appeared in your midterm. Okay. I think who asked this question is Matthew, right? Yeah. So you should check your Learn grades. The marks were uploaded like last Tuesday morning. Okay. So maybe I should post another update about that. But since I posted before, like on Monday, like grades will be uploaded on Tuesday, I didn't post anything, but your term test mark were uploaded like last Tuesday. So you can have a look, and if you have any question, you can contact me today's office hour. Today I have office hour from 3 to 4. Okay. So if you need any assistance, we can talk via next like this WebEx also. Okay, clear? You don't see any marks either. Okay. So can you just email me? I will double check then. If you appeared in the exam but didn't see any mark, please email me. Okay, I will double check. Please turn off your microphone if you don't have anything to ask or any suggestion for me. Okay. So going back to the slide. So any other question? Okay, we can go forward. Okay, so we covered the slide. So now how we can do the masking, like you know that there are many operators we can do bit manipulation with the masking things, right? We have AND operator, we have OR operator, we have XOR, we have a unary ones complement, we have shift left, we have shift right, right? So I will go one by one. So suppose give me, so let me give you one example, like how we can do another question. What do we upload our lab 6 material? So it's just like you know that for other course in UM Learn, you have something called Dropbox things. So I will create that one. So yeah, I will also give instruction in your course homepage. So how like from where you need to go to upload your lab contents. Okay. So on UM Learn, so another question is in UM Learn tab, I can only see assignment 0. I cannot access. Yes, you cannot because maybe you haven't accept the honesty declaration. Okay. So another is what is the team meeting code? One of my friend is having trouble joining the meeting. Team meeting code. Uh, what is that actually? Team meeting code, do I need to, like, what about the others? Did you put any kind of meeting code for joining? Anyone can just no, so you don't need, I think, right? Okay. You can just go to your DM Learn, then communication, then Cisco WebEx. You can see some link. If you so someone also share the code if you need also. I think so, yeah. Okay. So those whoever is not seeing the assignment, you have to just accept the honesty declaration. Okay, then you can see all the assignment. If you have any further trouble, please email me if you cannot see. Okay, so these kind of things, please I will request you to don't chat here, rather than like just chat whatever related to the slide right now. Okay, you can do these things like in email or in posting forum or like in discussion forum also, right? Okay, so if you have any question regarding the other matters, maybe after the class, I will just like be here like for another 10 minutes or 15 minutes. You can chat or you can talk to me. That's okay. But for now, let us just finish out to this topic or slide, okay? So that will be better, I think. Okay. So no interruption. So if you have any question regarding the slide for now or whatever I'm teaching now, just ask me in the chat. That is better. Okay. So going back to the slide, so suppose we have I bits, okay, then we want to do left shift by j places, then what will be happen? You know that those bits will be shift left, and then there will be some empty bits on the right, okay. So then the zero is filled up with those bits. So whenever you are doing left shift by j places, those j places will be empty and 0 will be there, inserted there. So same goes for the right shift as well, similar way, right? So I bits will be right shifted by j places, and you will have some extra like blank spaces in the left corner, right? And 0 will be inserted there, okay? Uh, what was that? So anyway, so now we're giving some kind of example here. We took like unsigned short I and j variable. So at first we are assigning 13 to I, right? And then in binary, you know that what is 13. And what we are having example here, so whenever you are doing left shift, it's kind of is incrementing the value, right? Because whenever you have these numbers, it will be left shifted by 2. So that means there will be two zeros at the very right places. So it will increment the number for sure. But whenever you will do the right shift, you know that uh, it will be less than whatever you had previously. So previously you had 13, now it will be 3 for sure, because those 1101, it's now is just 1 1, right? And we have some extra zeros on the left corner. Okay, clear? So rather than this also, we can also use compound assignment. What is that actually? Suppose rather than having another variable, we can just see I left shift equal to 2. Okay, it's the same thing. Or we can say I right shift equal to 2, same thing, right? So we are not using other variable, rather than we are just using a compound assignment. But you have to do like a less than equal sign. So if you forget that equal sign, it will not work. Okay, so now if you are using the compound statement, but if you have two things and some like two numbers, and you have some arithmetic operations, then what will be happen? So there are some like precedence here. So at first those arithmetic operator will work, and then you have the shift operator will work. So this example, I left shift 2 plus 1. So what it will do, the arithmetic operator is plus sign, right? So it will plus at first, okay? And then, so that means that I left shift by 3, okay? Not like I will be left shift by 2 and then whatever the content it will plus add, no, okay? So this is kind of a precedence we have for the arithmetic operator with left shift. Clear? I cannot mute everyone. The thing is that, yeah, so if someone has any question, what is the use of bitwise shifting? Uh, we can change the value. We will see. We will use another example later. Okay, clear? So I'm not muting you all, because someone has any question, you can just ask me the question rather than chatting if you want. So that's why I'm not muting all. Okay, clear? So the next slide, we have this example. Actually, what we're doing here, rather than the shifting things, we can go for you know that complement things, and things, XOR things, or things, right? So whenever we have these three variables, unsigned short I, j, and k, and there are some assigning three different values, you know that we are saying here k equal to complement I. That means that it's just flip the bits, nothing else. Okay, so you already know the logic for like AND operator, XOR operator, OR operator. So it will just work like that. So AND only works whenever the two bits is one, then only it will be one, otherwise it will be zero, right? XOR, if two bits are opposite, only then it's one, otherwise zero, right? OR is all the time one, except you have uh, zero and zero, right? Okay, clear? So you can easily do that. So we can also use the compound operator like this, like we can say I am and equal to j, right? Or I or XOR equal to j. Okay, I or equal to z, it's the same thing. Okay, we can use also that, the compound assignment with the operators. Okay, so with this bitwise operator, what we can do, like we can setting a bit. So that's our like someone asked like why we are doing these bitwise things. So it's particularly we can set a bit, we can clear a bit, we can test a bit even, right? We can modify our data like this, right? And then it depends upon what kind of like operation you need to perform, right? So whatever we have, that like 32-bit or 16-bit, you have to assume that the leftmost one is like the, if it is 16-bit, it will be just 16 minus 1, 15, and the very least significant number is 0. So if it is 16-bit, it starts from 0 and ends at 15, right? Like that. If it is 32-bit, it is start from 0 and ends at 31, right? Okay, clear? So, so how we can set a bit, right? Suppose we have a hexadecimal number like I equal to 0000, right? Okay. So if you convert it to binary, you know that for each number there will be 4 values, right? So suppose we want to set bit number 4, okay? Then what we need to do? So whenever we are going to set any bit, we can use the OR operator. Okay. So like this is an example. We are saying I OR equal to this hexadecimal number 0010. So we know that the bit is starting from 0, right? And it said the bit number 4. So that's basically like it's starting here from 0, 1, 2, 3, 4, right? So that's why we're having this OR 0010, right? So we are set a bit, that means the bit should be 1. So why we are using like OR? Because whatever the value is inside I, if I OR with 1, I know that for sure that bit will be 1. So that is why we are using this OR. Okay. And then rather than using this, we can also use kind of a variable which contains like how many times we need to shift, like that. Okay. Suppose if I write like 1 left shift J, we have this hexadecimal number 0008. How? Because 1 means like on the left side it has all 0, right? And we are left shift by J, right? So if j is the value 3, that means that actually it will be after shifting 1 0 0 0, right? And that is actually 8. Okay, left shift 3 will be 1 0 0 1. After 1 there will be 3 zeros. That means actually 0 0 8. So we can do also like that. Okay, for setting a bit, like for anything like that. So now what is a mask? So mask is like what we're doing here, we are changing, right? Mask is like if you have a number and you are masking the number with the operator like and with a value, you are changing it, right? So if you put a mask, you are changing your face, right? So if I mask any variable 10010, yes, it's a hexadecimal. Okay, so let me finish that mask thing. So whenever we are manipulating any number with the operator and some value, it's kind of changing it. Okay, so that's why we're just saying masking it. Okay, nothing else. And then whenever you see a number with x, that means hexadecimal for sure. Okay, so this was like very first classes topic, I think. Like in one class I said, whenever you, if you see b, that means binary. Okay, if you see d, that means decimal. If you see x, that's hexadecimal. Okay, clear? So yes, 0x0010 is a hexadecimal number. So any more question? I think we're all good. Okay, so then how we can clear a bit, right? Okay, suppose I have this number hexadecimal number 00FF, right? So if you convert it to binary, so this is the binary number, right? And then we are using an AND operator here, right? So we are saying clearing a bit. That means we are like clearing means just set it to 0, right? Okay. So whenever we are using AND, actually with this complement sign, right? Okay, so that means that actually we are ending with that particular bit like 0. So you know that whenever you have to clear a bit, you can just use AND with 0, right? So whatever the original content is, if you AND with 0, that bit will be clear, like it will. So if you do any bit with AND 0, it will be 0 for sure, right? So by the logic gate. So that's why we are using like this. We are saying I and equal to, then we are saying the bit number 4. So again, it's the fifth bit. That's why we put in 0010 in hexadecimal number, and then we just complement it because we are ending with 0 for clearing that bit. Okay. So now, so I will be, you know that fifth bit is 0, rest of the bit will be same, right? Because if you just end with 1, so it will be just whatever the bit previously was, it will be remain the same thing, right? That's why. Okay, clear? So also we can use some kind of variable for clearing the bit, like I then left shift J, like that. Okay. So rather than directly giving the value, we can have some variable like which position we want to clear, and then we can do like that. Okay, clear? Any questions so far? Okay. So then how we can test a bit? For testing a bit, we can use the if statement. Okay. So suppose we want to test like what this bit is for. Is it 1 or 0, right? Then we can go for if and then the particular variable and with that particular bit. Okay. Then looking at the result, we can see that whether it's a 0 or it's a 1. Clear? Okay. So going forward, so this is the one, like I said, like I will give you one example, like so for where this bit manipulation is applied actually. So if you can remember, so this one we talked before, like this is a kind of a game. You can do kind of programming things. Sorry, yeah. So this is the one. So we call this Game Boy Advance game, right? So here you can program in C, and then suppose if you have some kind of color, how we can change the color, like in here in the screen. Okay, you can set the color, and then it's kind of a bit manipulation actually. So in this game or in this circuit actually it's kind of 15 bits, and each of the color contains 5 bits. So you know that for any color, it's represented by RGB, right? So R is for red, G for green, and B for blue. But you can have different number to represent different color, okay? So in this Game Boy Advance things, we have 15 bits for representing color. So you know that this is starting with this B, that means binary. And you know that at first we have representing blue, like the very first 5 positions are representing blue color, then the next 5 bits representing green, and then next 5 bits representing red. Okay, so suppose we want to encode the purple. Okay, so for purple, our code is R is 21, G is 0, B is 25. That means if we put R red as 21, green as 0, and blue as 25, then we'll get this purple color. Okay, then how we can do it, right? So let's see the example here. So we know that 21, okay, if you convert, so this is the one like in decimal, right? So whenever you see it in 10, that means decimal representation, right? So then if you convert to binary, this is the binary number. If you convert to hexadecimal, then 15 is the hexadecimal number, right? So this is for red value 21. For blue value, similar like that. For the green one, similar like this, right? So maybe we can just declare some unsigned variable here, like color equal to 0. Then what we can do here, you know that in the previous slide the very first thing we have blue, right? So but now whenever we declare a variable blue, right, in hexadecimal number 19 or binary number actually 11001, right? So what you need to do here, so in the like Game Boy Advance, that thing, the color coded as the very first 5 bits are blue, right? So what we need to do, we can do left shift, right? So that's why whatever the value we have blue for, we are just left shifting by 10, so that we will get the very first things, very first 5 bits as blue. Okay, clear? And then you know that this is the code for at first blue, then green, and then red, right? So we are just left shift our green value by 5, so that we will have on those portion the green values, and then the very last one is red. Okay, so that is how we can design, right? So whatever the value we have, we can just left shift so that we can do as we need. Okay, clear? Using the left shift we can do that. So this is kind of an application of bit manipulation or masking things, right? Clear? Is the example clear to everyone? Or if you have any question, you can ask in the chat box, or you can speak if you want. Okay, clear? So this is your activity with the next person. So it's, you know, like it's a class things. Maybe I'll just delete the slide. You can pick a color. You can just convert it. Okay, just like that. So now how we can represent in the code, like in C code, you know that whenever we're saying bit manipulation, it's not byte, right? So can we do that in our C code? Can we mention, can we specify certain number of bits whenever we're declaring a variable? Yes, we can do that. What's the way? Suppose I'm just declaring a structure called flux, and then for chair, I'm just declaring assigned chair. Okay, I just need, if I just need 1 bit, I have to use this colon sign, and I can see like how many bits I need. Okay, so this means actually number of bits for that field. Clear? And for sure, you know that only there can be two values, right? So since this is just 1 bit, it can be either 0 or 1, right? Okay, so just like that, you can have this the other members also, like we are just having 1 bit. Okay, but the thing is that whenever, so maybe you are assuming that if you just print like size of this struct, you will get 3 bits. No, actually. So whenever you are declaring struct, so so altogether it cannot take less than 1 byte. Okay, so though you are having these 3 bits here, but in together whenever you are saying as a structure, okay, you will get 1 byte, and that 1 byte will be shared between among those variables. Okay, clear? And then for assigning or accessing the things are similar, like you can use dot or you can use the arrow things. Okay, like I can say that struct flux name of the structure, and then I can give a name so that I can use that name rather than using the whole line. Okay, and then I can just say flux dot is high equal to 1, just like that. Clear? Any questions so far? Okay, so this bitwise manipulation, like actually it's not recommended. Okay, so why this is not recommended? Because the compiler store bit fields is implementation specific, and also it's architecture dependent. The thing is that if you like code in Linux or Ubuntu, and then if you run it to Windows, your bit things will not be same, and you will not get the actual input whatever you are getting in Linux or Ubuntu. Okay, so it will be changed. So if you don't
change your platform, then it's okay, you can go for bit manipulation. But if it's not flexible then, or it's not like you cannot do one platform, you can code one platform, you cannot run it in another platform. Okay, the flexibility is not there in bit manipulation. Also, the casting and overlays don't always work as intended. The thing is that suppose with the bit manipulation you have written something in the file, okay, and then if you again read that, it can be changed afterwards. Clear? So that is why this bit manipulation is not recommended if you change your platform or if you work with the files things. Clear? Okay. So now, when do you optimize, or like if you do this optimization things using the bit manipulation rather than byte, right? So our main topic is kind of space optimization, right? So then why we're interested in bit manipulation? The thing is that if you don't need a byte, you can go for the bit, right? And it will reduce the size, right? Okay. So if you but you have to be careful that whenever you do that, you are not working with file and you are not changing your platform, you are just restricting the same platform you are coding. Okay, so when we are doing the optimization things, right? So you can use the bit fields to control the range of values as well. So suppose whenever you say that you are using 3 bits, okay, so it will cycle around with the mode 8 architecture, arithmetic, sorry, okay. Whenever you are using the 4 bits, it will do for mode 16 arithmetic, right? Okay, clear? So that is 0 to 7 hexadecimal, and then 0 to f hexadecimal. Like I cannot hear anything. I have rejoined the meeting 2 times now. Uh, okay, I think I am not. So there is a question. One of your friends cannot hear. So some of you already give some suggestion. I think that will work. I'm not an expert in this Cisco WebEx. I just using today actually. So maybe you can post it on the like discussion forum. Then I will contact IST and then I can have some solution. Okay, clear. So we are okay with the slide. Any questions so far? So if you go for this three, like 3 bit or 4 bit, so you have this range of values to play with. Okay, you have this. So there is a nice article of Donald Knuth, like when you can, or when do you optimize actually. So I can just have a look here. You can just read it in your leisure time. Okay. And there are actually two places we do optimize things. Like whenever, so at first you have a problem, right? Okay. So whenever you have a problem, rather, so I already discussed in the class that rather than going for the solution in your compiler or in writing the code, you should get a pen and paper and you should design it, right? So if you think that you should go for like the space is the issue with the problem or the solution, you should go for the in the designing part you can do the optimization things, right? Another thing is that uh, maybe you should at first look like whether your code is working or not. Okay, if your code is working fine, only then you should go for the optimization, right? So suppose you are wasting many times in optimization and then your code is not working. So that shouldn't we expect, right? So we expect our code is running and then we go for the optimization. Clear? Okay, so now we are having another topic, right? Uh, we already discussed this topic, but there was some extension with this topic, and the topic name is dynamic memory allocation, right? So what you know already, that is, we need the keyword called malloc for dynamically allocation things, right? and then maybe you are working with it with the assignment number 3. Maybe you are working like dynamically allocated the container things, right? Okay, so what it does, whenever you allocate, right, some dynamic memory, right, so we say this as contiguous memory location. So what means contiguous? One after another, right? So it's not discontinuous. So contiguous means like kind of continuous. It's just one after another, like in a train, you know that the compartment is just joining one after another, right? So if you want to go the very last one, you have to traverse from the beginning if you are in the like number one compartment, right? So just like that. Okay, so now whenever we think like this is a contiguous memory location, so it represents actually an array, right? Clear? So so far we already know like how we can declare mal or how we can use malloc. We it should be a pointer, right? Suppose integer type pointer, right? And then we can assign malloc and size of the integer. So this is just like allocating space for a single integer, right? Okay, so what if I want to declare an array of integer? What I need to write? Okay, so it's very simple because these are the contiguous memory location. We can just simply say that malloc size of integer multiply into how many array member I have to declare. So if I have an array with 10, like size is 10, I can just multiply into 10. Okay, so this is the way how we can declare dynamically allocation of the array. Okay, clear? Any questions so far? Okay, so hopefully whoever is having problem sometimes muting you, mic, you mute your audio so the person is mute instead. Anyway, so I think it's solved anyway. So suppose let me give you one example here. Okay, so we have a structure. In this structure we have two members, right? One is integer and there is char, right? So you know that for integer we have allocated normally 1 byte. For char we have 1 byte. So this structure in total is allocated 2 bytes, right? And then we give a short name for this stuff, right? And then we are saying that this a equal to malloc, we are saying 10 times size of stuff. Okay, so what we are doesn't so I have there is a question actually. Doesn't malloc give you a void pointer? No, void pointer, it will give you a void pointer, but if you just declare like a pointer of what kind of things you need, then it will not. Like for this example, it's not giving you a void pointer, right? Because you are saying that I need a structure type pointer, right? And then we are allocating that space to that particular structure, right? Okay, so is that answer your question? Maybe. Okay, sure. Okay, we can carry on. So, so here there is so I don't have any board here so that I can explain more about this. So anyway, I am just describing here like what we are doing here. So you know that so if you just draw a picture in your mind, you have starting the address with 0, right? Okay. So 0 and 1 is the very first element of the structure, right? Okay. So then number starting from 2, actually it's the second array member, and the array is type of structure, right? Okay. Is this kind of visualization is clear? Like what we're doing here? Because we are saying size of stuff. Size of stuff is 2 bytes, right? So we are allocating the array, dynamically allocating that array like that many bytes, right? Okay, clear? Any question so far? Okay, so now how we can access a particular array member then, right? Okay, so it's the same like whenever you are accessing an array element in Java, kind of same, like we are saying a subscript and then the index. Clear? So suppose I want to access the sixth element, right? So it will be a5 dot maybe whatever, means like you can do for junk, or like the char is whatever. Okay, so that is how it works. Okay, so whenever you are saying a5, that actually represents that you know that a5 into size of stuff, right? So that means it will go to the 10th position. So actually there your basically the fifth or sixth array member is it clear? Okay, so enough bytes for the entire structure we're saying, because each of the structure contains 2 bytes, not 1 byte. It has 2 members, right? Each of the member is 1 byte. Okay, so you have to all the time thinking about, you have to think about that, like you have to multiply whatever the number here into size of that structure, right? And then that's your or like actual address, right? Okay, it works like that. Clear? Any questions so far? Okay, so that is what we're saying, like what is actually happening here. Malloc allocates n bytes of space. It doesn't know what an integer is, right? So it's just number of bytes it just represent, right? Okay. Compiler also overlays the type on the bytes. Clear? Normal array, yes. Normal array, yes. The concept is like whatever the address it is starting from, if it is starting from 0, it depends upon like it depends upon so if it is a structure, you know that there will be some member here, so you have to be careful about size of that structure. Okay, and then you need to multiply with that. Okay, so this is important, like you have to say size of structure if you want to declare like the 10 size of that structure, like 10, like the array of structure with the size 10, and each of the array member is representing a structure. Clear? Is it clear? Okay, so okay, okay, so the thing is that so you know that we are having pointers to integer, we are having pointers to structure, right? So but in big picture actually you are just representing some address, right? You are not representing kind of whenever you are accessing there is no, it's not making sense like what kind of data structure I am using, right? Is it structure, is it integer, is it char? It doesn't mean anything whenever we are allocating dynamic memory, right? It's just like kind of an address, right? So that's why we are saying that there comes the point of like the void pointers. If you don't need the particular kind of pointer because it's all about the addresses, right? Then why do we need that, right? We can just declare a void pointer, right? So how we can do that? Okay, so let me show you one example here. I also uploaded this code in your learn. Okay, so here you know that we have the this is a structure here. We have 3 members here, right? We have a buffer size called 124, that is 1 kilobyte, right? And then inside these functions, okay, So we are passing a void pointer rather than saying like what kind of pointer it is. And depending upon this function, depending upon the the target of this function, we are then casting it to type. Okay. So in line number 17, we are casting this pointer to chat type. Okay, because we in this function where we need that. Okay, and we're filling something, we're filling this char array with the character. That's why we're casting it to char type. Again, in this function, okay, what we're doing here, we know that we're working with this structure, right? So whenever we are passing the value, you know that this is we're just passing as void pointer, and then we are casting it. Okay, so whenever you are not sure like what kind of pointer you have, you can just use void pointer and then you can cast it. Okay, so if you run this code, it will be just at first an integer and then a double and then a character here. So I think we are out of time today. It's 2:21. So I will post this recording in your Learn. So now I will be available here. If you have any question, you can do in the chat or you can ask me. Okay. So I will again we'll not see. We'll do our online class on Monday at 1:30. So have a wonderful weekend and stay safe, everyone. Okay. Thank you. Bye. So about the final, most probably it will be an online, yes. So either CrowdMark or in Learn things. Okay. So it's not finalized yet. So there will not be any in-class exam for sure because the situation is not normal yet, right? So we'll go for the online things for sure. I will keep you posted in Learn. So I will request all of you to just go to your course homepage, maybe sometimes in a day or like each day once, maybe at night, so that you will be updated, right? So all the updated things will be in in your Learn homepage. Clear? So will the weightings of the grade change at all? For now, no, because we are still going on well. Like we have the assignment deadline on 28, I believe, and then the next one will be there. And we're for lab, everything is okay. And so for now, there will not be any changing of grade. So if I convert it, I will post it. Okay. So what's the difference between casting and masking? So casting, you know that you are changing the data type, right? So in the masking, you are not changing any data type. So whenever you are casting, right? So suppose from void, you are changing it to chart type, right? From void, you are changing it to structure type. That is, we are calling casting, right? But masking is we are not changing the data type, rather than we're changing the value, right? Is it clear? Fraser, I think. Yeah. Okay. So, Gurmanchur, are you clear with your question? The weight for grades for now remaining same. I will let you know in the Learn homepage if I change anything. Okay, clear. Another question from Matthew. Will I be able to see my midterm on CrowdMark or something? I want to see my mistakes. What I can do, I can show you via online also. I can do that. So you know that by hard copy. So what happened actually? I requested them to. I also discussed in the class. I requested them to print one-sided, but in the office, computer science office, they printed both-sided. So whenever they rip it off the left corner, the QR code got ripped off. So the CrowdMark didn't work properly. I had to examine each of your script one by one with the hard copy. So there is no way I can show you
on the crowd mark. Okay, so if you need to see it, you can call me in my office hour starting from 3. I'll just like put you in, like, in front of the camera so you can have a look, I think. Or I can tell you like what kind of mistake you have done. That is also possible. Is it okay, Matthew? So from Amandeep, any course change overall? Still not, no, not any course change. So we'll do normally with your online lectures. Maybe if we left over any classes, I will put just those video online. If I don't have any like enough class, what I can do, I can just put online lectures available in UMlearn. From Tahmid, do we have to submit Lab 6 online? Yes, you have to. I will just create some Dropbox so that you can submit your Lab 6. Is it clear, Tahmid? Okay. So, do you have any further questions left from anyone? You can ask me any question if you have. Officer 3 to 4 on WebEx like this. Yes, Matthew. Yeah. Maybe I will just put some link on your EMLearn so that you can have the particular link to join. Maybe I'll just put some break between some slot so that one after another I can contact with you guys. Okay, sounds good. Uh, if you have any other question, you can ask me, or I will just end the meeting. Any more question from anyone? So I will request you guys to stay safe, everyone. Okay, no gathering, no party, social distancing between you and anyone else, like 3 feet or 2 meter or 6 feet, I think. Yes. All right. Bye then. Talk to you soon on Monday then. Have a good weekend.